On behalf of the India Energy Forum, I am very much delighted to welcome all eminent participants to the webinar to discuss the challenges in the implementation of concentrated solar power technology and pivotal role of R&D. The forum is a premier organization to have policy advocacy dialogues in different vortices of energy under the guidance of our President Shri R.V. Shahji. Energy research and technology is a new addition. T is used because we thought T can create an impact rather than D. This is our first webinar. We thank Dr. Ms. Kalai Selvi is not there, sorry, didn't see her. Dr. Mahesh Sharma for joining us as presiding the event from CSR. To give the background of the importance of CSP as an energy technology, I may add that India is, you may agree that one of the early starters in initiating the use of solar thermal power and also the planning for high temperature. But while low temperature applications got boosted and have flourished, total capacity in high temperature remains minuscule, as low as 230 megawatts as against the total global capacity of 7.2 gigawatts. So what I also wrote in the concept note, why India has such a minuscule share? Is it a lack of investment, lack of technology, lack of decision making, or research and development? This is what we are, how R&D can play a pivotal role in overcoming the challenges. This is the topic of discussion today, the webinar. I welcome all distinguished speakers to address this issue. Next. Yeah, Shri. So noise is coming.
Others should mute, please.
Okay, so this is the first webinar. Next one, next. As you would all know that CSP is a technology that utilizes large number of mirrors to concentrate sunlight to generate high temperature heat, and thermal energy which is used to create heat the fluid, which produces steam and activate the turbine as other electricity devices. Next. So, as you all know that CSP system can include various methods, which are parabolic trough, long troughs, central receiver system, and parabolic dish. These are the main configurations. And first, before going into much detail into the technicalities, I will go to the next pros and cons of CSP. Next. Sure. Pros and cons for policy advocacy of CSP versus other tech. What are the pros and what are the cons? Now, pros is clean. It is a clean, non-polluting fuel. No fuel cost. No fuel is used. Hence, potential to conserve fossil fuel resources. Can be efficient and cost-effective. Permits dual use of process. It can be used as heat, process heat as well as electricity. So industry can make use of other than power. Can be executed in different existing industrial base and reduces greenhouse emissions to provide a solution to climate change. So what are the cons of using CSP? Low energy density. Vast areas required for producing the same amount of electricity as compared to other fuels. High upfront cost and long payback. Large area, I said already. It requires high direct normal irradiance. That means limited locations for choosing the site. Plant size limitations are also there. Then there are ecology issues, the surroundings. Then competition in the long run with new technologies like phase change materials and thermochemical. Now there is a trend already that when new materials are being discovered, it will be having competing with the CSP technology. Next. So it is estimated that around while it is beneficial to have solar thermal to have a storage, so which allows it to not intermittent, it is not intermittent, and it continuous power can be obtained even in the night, and it is free from pollution. But a 40 megawatt plant may approximately require 2 kilometers square of land. So in such a situation, if a 400 or 500 megawatt plant comes up, it would need about 15 or 20 square kilometers, which is enormous. So the vital question is what has changed in last 30 years? Because it is always said, is it really happening or it is stable? To create resurgence of interest in CSP, I think there has been some reduction in cost significantly from 2010 to 22. I remember doing a study in 2010 and found that there was hardly any research publications on solar thermal from Indian side in Web of Science. There may be others, but in Web of Science. Then high temperature now can be reached instead of 550, which was there in 2005, 2010. It is now, one can go up to 1000 also. Long duration storage capacity can be developed, making it dispatchable power. Now with the new materials, new storage systems, storage capacity has increased. Modern systems integrate advanced low-cost thermal storage using molten salt or other materials. Designs can be modular and can be integrated with other renewable sources also for making a plant, grid-connected plant like PV or fossil fuel. New materials used in selective absorber coatings with high temperature alloy improve durability of the system, and the changing technology choices which are happening now. So maybe we will discuss them now. The key ministry, I thought, next one. Key areas of research can be identified: the mirrors and collectors, advanced heat transfer fluid storage systems, integrated CSP with other systems into hybrid mode, and new materials which can withstand high temperature. Because once we need to go up to 1000, we should have materials. And Ministry of MNRE is a key ministry. Dr. Anil Kumar was to come join us, but he has been called by PMO. But would like to say that it is one of the thrust areas of Ministry MNRE, and it is Indian standards for all three configurations are there, like IS 16648, and it is more. It has a focus on heat, more also in heat. We will hear Dr. Anil Kumar is not there, so I am not communicate much on that. But in all, there are about 9 CSP plants. This is a data which is collected from solar places database, NREL USA data solar base program. I have not checked the availability. Maybe experts can tell more about it. But it says that 5 are there in operation and 4 are there under construction. How much correct? I would not be able to say. I do remember that solar bases have invited from India to participate when they were putting up a plant in Spain, but that could not be agreed anyway. And I have seen this central receiver system in Israel in 1998. So that is a compact system. Comparing the cost of 3, of course, the parabolic trough may be the least cost intensive in construction, whereas the central receiver system, electricity cost is less and area requirement is less. So there is a shift taking place in the technology, the new technology, from trough to central receiver system. Now we have from SECI, Shri Abhinav Bharti, who has vast experience, and he is working in SECI for last 12 years. So he will apprise us what are the challenges in implementing their 500 megawatt plant, which is not mentioned here. It's other in 9 plants. So what is the status? Because I read that tender was issued in 2024, but I'm not sure whether I'm correct. So I would summarize saying that CSP technology, can we go to the next one? Next. Okay, some of the innovations which are taking place that linear pixel reflected, which are the plane mirrors, not curved, and also making a closed parabolic trough design inside the greenhouse, creating a covered glass house. I mean, these are the options which are taking place, and also development in accurate solar resource data monitoring is vital for the success of a plant. So addressing these implementing challenges required a concentrated efforts with R&D at the forefront, continuous investment in materials, storage and system, that is the area of R&D, can improve performance and can compete with other energy sources. With new guided investment, CSP could become an important part of India's clean energy mix and accelerate its crucial role in global energy transition. So I thank you very much. Next one. So I just want to inform that we have also published a book on solar energy, Made Simple for Sustainable Future. And that was by Springer in 2022. And I am happy to share that it already has 10,000 global accesses and is available both as soft copy, e-copy, and hard copy from Springer. Thank you very much. So, I think I have given the introduction to the challenges, R&D challenges, and I have not touched upon the technical and policy challenges, which we hope to hear from the distinguished speakers today. I invite Shri Ari Shai sir, President of the forum, to say his perception about the CSP technology and its future development in India, and guide us future development in India. Thank you, sir.
Thank you, Mrs. Malti Goel. And this was a very comprehensive introduction to this subject of concentrated solar power. This is a subject which has been under debate for not years, but for several decades. And my own familiarity with this is as old as 1991, when I was functioning as Director of Operation in NTPC. And Mr. Sharma had taken over as the Secretary of Non-Conventional Energy. So in the beginning, what is MNRE today used to be a part of Power Ministry as a department. And then some years back, when I met Mr. Sharma, who used to be Joint Secretary in the Ministry of Power and later on National Secretary, when he became Secretary, he was the Secretary of what is today Ministry of New and Renewable Energy. And he told me that there is a concentrated solar power at the outskirts of Delhi, between Delhi-Gurgaon border. Gwal Pahari is the place, and that had been taken as a model, and this is not functioning. This was not functioning for years together. So can you make a visit? And that was the first time I heard about this. So before making visit, I did some literature survey of something that had been done on California and USA. So everywhere in the world at that time also this subject was very interesting, that you store the energy when solar radiation is available and use it when it is not available. Since then, I think a lot has happened in the field of new and renewable energy. Solar has occupied an important position. And in that context, what is the relevance of this? One has to evaluate, because now there are so many options. Solar power itself in the last 10 years, just 10 years, has come down from something like 15 rupees per kilowatt hour to now in the range of 2 rupees 30 paise, 2 rupees 40 paise. So there are many other options which were irrelevant those days. Many other options of storing energy and converting it into power later on when solar power is not available. Those options were not available then. They were not available in 60s, 70s, 80s, 90s. And they were not available even till 2014-15, when the solar power in the new incarnation came to light, and India gave a boost. And at that time, some of the 30, 40 megawatt power station, the price was as high as 14 to 15 rupees per kilowatt hour. So it's a matter of last 10 years that the scenario about what should be the approach of technology and what should be the approach of planning in trying to store energy and use that energy or convert that energy into power at a time when solar power is not available. Many, many options. Now, in those options now, where does this concentrated solar power fits is a matter of evaluation. Even now, I have done some literature survey. Even now, there are questions about reliability of irradiation that causing a problem to them. Fortunately, what Malti presented today, I had not seen this table, that you have about a dozen power projects which are either under construction and a couple of them under operation. The two power projects which are under operation, one is Jaisalmer, I saw in the table, and it has an experience of maybe last 3-4 years. It would be good to find out what is the operational experience of this. This is the senior most now in the new incarnation, not very old, last few years. So what are the experiences and what are the feedback of this power station in terms of operational challenges and in terms of also cost? What is the cost of power that it delivers? And then we should need to evaluate, because so many options we are doing in the country. And as I said, that today battery has emerged as one, hydrogen has emerged as another. And just a few months back, very simple application, that you just lift a weight. You lift a weight of sand or even steel blocks, and store that energy up, use that solar power, and keep that energy stored. And when you need power, you allow that to fall at a speed and rotate your rotor and generator, and you get power. So I think so many applications, and these applications have become relevant because solar power cost in India during daytime, you will see, and that situation is already emerging, that whatever capacity is built up, even at 100 gigawatt plus, we have solar power which is not being used during daytime. So some of the power projects which are large capacity power projects, they are asked not to produce full amount. So there is a waste. So therefore you will have a lot of power, solar power, and fortunately we have the two, three exchanges in India. You will see the cost of power during daytime, solar power, will be almost negligible. And many of you might have heard that in European countries, you are paid, not you are given the money. You are given incentive to produce power, not that somebody has to give you to just balance the grid. So that situation, you will have almost solar power almost free or at negligible price. And that solar power you will be able to use in technologies which can store energy and then produce power in the nights or in the evenings. So I think you have half a dozen options available today. And Indian companies are working on all of them. So it is in that context today we have a good number of experts who have worked on this field, and we would like to hear. And I would be particularly interested to know how is the operational experience of the Jaisalmer, which is the senior most in the series or the list that Malti just presented on the operational experience. My one thought is that perhaps it still has issues. It still has issues, and anything has issues. Whether they are solvable, they are not solvable. Compare it with the storage that you will be able to do with, let us say, battery. Out of many, hydrogen is also that is coming up. Out of many options that are coming up for the evenings, that is the battery storage. battery storage with a required capacity of megawatt hour for 2-3 hours to back up large solar power generation. And during daytime, you have the capacity in a manner that a good part of that capacity you are using for typical power applications, and a small part of it you are using to charge the battery. And then keep that energy and use it in the evenings. So like that, the options are coming up. So let us have a critical evaluation of whether, so far as government system is concerned, they are very positive. They're positive in the sense that every technology that is coming up, response is good. We have to see how our researchers, how our professionals, energy professionals are able to solve. I said that my familiarity in 1991 was that it was not workable. It did not work. Terry was very deeply involved in this, others were involved. But 91 story and today the situation is entirely different. And its relevance today has to be fixed in terms of how does it compete or how does it complement or how does it help in still pursuing with this. Does it, of course, battery has its own environmental ramifications. Pump storage is coming up. Pump storage will take some time, but 4 or 5 years time, we will see something like 10,000 megawatt in a matter of 4 to 5 years coming up on the scene. Maybe later on, maybe 50,000 megawatt will come on the stream. So therefore, there again, you are using the cheap power during daytime and storing that power and producing this hydropower during nights. So that is another good system, and that is quite environmentally quite benign and favorable. So these are so now this particular technology was under sympathy those days. It was struggling on technological compulsions and technological challenges. Today, technological challenges of this technology, whether they have vanished, like some of the points that pros and cons just Malti was trying to put on the table. And in that, material is different, design has been changed, but at the same time, there are other difficulties still continuing. With all these put together, are there successful cases? Concept-wise, I don't think much has changed. Concept is same, that you are using this. But what has changed and what are the operational experiences of those design changes, operational changes, and more importantly, like it is a question today to all technology development, how does it become affordable? As I often say, the research is good, something you innovate, and anything that today is being talked in India and in the world in the field of renewable energy. There is nothing which was not talked 50 years ago. But 50 years ago, they were not accepted because they are not accepted in terms of economics. Same thing. We're talking, everything we talked 50 years ago, again, we are talking the same thing. What has become affordable in terms of economics of its production, economics of its operations, manufacturing, whole range of things put together, that makes all the difference on research. And that is true for any research project. There are some research projects where, okay, we keep spending money, we still try to do some innovation or the other, but finally when it is accepted in the market is the point when it becomes an acceptable range of prices. So let us hear from the experts, and I would really look forward to listening about some of the successful cases. So with that, again, I welcome you on behalf of the India Energy Forum. And after discussions, I'll come back again toward the end. Thanks a lot.
Thank you, sir.
Yeah.
Yeah. So I really welcome all the distinguished speakers for the meeting today. And let me just introduce them briefly before I ask Dr. Mahesh Kumar to chair the session. Dr. Mahesh Kumar himself is a hardcore scientist in optoelectronics at an National Physical Laboratory earlier. Now he's the head of he's the senior principal scientist at the CSIR. So he will be chairing this session. He has vast experience in the research side, and I think he will be able to suggest the ways and means how we can make the implementation effective, as has been told by Shai sir. We have Shri Rajan Varshney, who is an experience from the industry. He has taken several initiatives and he did MTech from IIT Delhi and MBA. And he's passionate about CSP and environment and sustainability and circular economy. So I think he will be giving his views about the industry viewpoint on CSP development. Then we have Professor Manush Soni from BITS Pilani. He is an academician, professor of mechanical engineering department, and he is coordinator for Center for Renewable Energy and Environmental Development of BITS, that is CREED. I find that he has been coordinator for various collaborative works and learning programs of industry. So he has experience both from academic side and industry's application side. We have also, as I said, Dr. Anil Kumar will not be able to join perhaps. Dr. Abhinav Kumar from SECI, that is Solar Energy Corporation of India. So he is will be joining us, and he has done his MBA from IIT Delhi and BTech from Jamia Millia Islamia. He is working in SECI for last 12 years, and he is a DGN there. So he has worked on regulatory strategy formulation, collaboration, business development, and contract project financing, etc. at SECI. So he also has vast experience in management of solar energy. So with this, I will just put this podium to Dr. Mahesh Kumar to kindly chair the session and conduct the proceedings. Thank you, sir.
Thank you very much, ma'am. And good evening, Professor Shahi and all the dignitaries. And am I audible? Yeah. Okay,
yes,
that's good.
Very much.
Thanks for conducting this webinar. And I, as a researcher and currently as an administrator on the other side at CSR headquarters, I appreciate these efforts because as ma'am has mentioned in her note that despite of gaining the early lead in CSPs in 80s and 90s, we are not able to fully utilize these CSPs. Apart from this couple of the chart which ma'am has shown, even I was not aware of 175 megawatts of this CSP power generated in Jaisalmer, apart from the small other things. Apart from that, this is almost nowhere. In some guest houses or some hotels, you can see CSPs for heating the water during the off time. But despite of that availability of so much huge solar power in India and diversified conditions, we are not able to tap this through CSP. And CSP is one technology which is just a one-time investment. You just have to fire and forget type of technology. Even then, we are not able to like familiarize it and popularize it amongst the users. Multiple reasons could be there: lack of support, lack of infrastructure, lack of other things, and lack of confidence. Like people have started using it and somehow they stop using it. There are certain technological issues, certain materialistic issues. For example, the coatings which are used in these CSPs, they are generally highly corrosive. They become and because if you go from north to south, east to west, the water content varies drastically. Even from Delhi to Gurgaon, if you move, you'll find huge fluoride content. If you move towards other sites, there are other calcium content, and they deposit inside these tubes, and then it's very difficult to flush out so rapidly. So ultimately, the technology which we are supposed to last for 25, 30 years, 40 years, it just corrodes within few years, 2, 3 years, 4 years, 5 years. As an experimental CSP, we have, when I was in NPL as an active R&D scientist, I set up one CSP tube in on my solar on the rooftop for heating, for getting the like heat for waste heat, or to utilize that heat for certain applications, especially for thermoelectric power generation. So, but after 1 or 2 years, because there the chloride and fluoride and calcium content is so high, after just 1.5 years, the tubes blocked. And the supplier said that, oh, you have to replace those microtubes, and, or you have to completely change, throw this CSP and then replace it with a new one. So these are the issues. This is a very challenging issue, which definitely creates a lack of confidence amongst the users. So as a CSIR, when I left NPL and now I'm in CSIR headquarters, tackling various projects and managing various projects from the background, from the other side of the table. Now I realize that, okay, CSIR has a lot of potential. Like NAL has long back developed a technology, spot coating technology, which is a very hard coating and can prevent the corrosions. NPL itself has a expertise, and they have transferred the know-how in developing the coatings inside the tube. Inside the tube, coating is very hard. It's not so easy. So now, right now, people are working, doing this polyethylene and other things, which generally corrodes after a few years. But if we do the coating inside from the plasma technologies, which is NPL has available expertise, I can bet it can last for at least double the years, which has been supposed to work out. So these are the two things, like if we use the NAL technology on the outside and NPL technology in the inside, and then tackle the corrosion issues and other issues, because water we cannot change. Water is available. Water we cannot change from place to place, but we have to install those CSPs at those places where the water is too hard and it can create corrosion instantly. So we can use this type of specialized coatings, hard coatings, which will reduce the corrosion definitely. So this is one aspect of the technological challenges which is preventing this technology to flourish and to get popularized. Another thing is that though we had taken the lead, still the CSPs, most of the CSPs, they are coming from abroad. China is supplying most of them, and the other countries supplying, and they are manufacturing and these tubes as per the requirement of the European countries, American countries, and other countries. And when we use it in our country, they generally fail because they are not prepared as per the Indian conditions. So when I was in NPL, I always advocated that we have to develop the technologies as per the requirement of Indian conditions. That means we have to develop the standards which are applicable in Indian conditions. For example, if technology can work at minus 40 degrees Celsius in Ladakh, it should also work at 50 degrees Celsius in Rajasthan. So because we have a huge variation of temperature, weather, all conditions change after for 50, 60, 100 kilometers throughout the, if you move from one, in the country from one place to another, every 100 kilometers conditions change. So those technologies should be so rugged that they should withstand that complete temperature and the conditions which are varied from one place to another. So we have to develop the standards as per our requirement and should not follow blindly what the standards are made for the European countries or the Western countries, because they have a very stable temperature, a stable environment. We don't have the stable environment. And another good example of this, ma'am has cited these examples. So RKDF University Bhopal, they have utilized this solar thermal very efficiently in their CCUS plant. So with utilizing this solar thermal in their CCUS plant, they could reduce the energy penalty drastically. And just 2 years back, as a CSR, I personally signed an MOU with RKDF University, and 4 or 5 labs of our CSR labs are taking advantage of that plant, and that has saved us, you won't believe, more than 50-60 crores of rupees. Because if we develop at CSR one plant, it costs around 15 to 20 lakhs, and just making a collaborative efforts with RKDF University, we could save 50-60 crores. That's a huge saving of government. So that type of collaboration is also needed, and collaborative efforts are also needed to like popularize this CSP in India. And of course, the R&D, not huge R&D efforts are required, only small efforts in R&D are required, so that small regional issues in setting up these CSPs in specific regions where we have to generate the confidence amongst the user has to be increased. So first thing, in order to popularize this CSP technology is to generate the confidence amongst the user, whether it's a government user or a private user, they have to have confidence in this technology. So the ruggedness, the toughness, the standards, and the longevity, these are the few issues that we have to tackle. And of course, the standards are to be as per the Indian conditions. So that's what I can say from my side. And thanks, ma'am, for giving the opportunity to CSIR for speaking on CSP. And I would like to have this CSP technology flourish and popularize in Indian at various places, because the sunlight is free of cost, and we have a huge sunlight to tap.
So we invite Shri Rajan Varshney, who is also working at LTPC as DGM.
Mr. Varshney, we are unable to hear you. Please unmute yourself.
Good evening, everyone. Thank you for having me here. Thanks for setting right context, Shai sir and madam and Dr. Mahesh. I would like to discuss on the aspects which have some of the aspects which have been discussed right now, but to complete the discussion, I would start with the table which was shown. The first plant, that 125 megawatt plant itself, came during that Jawaharlal Nehru Mission 2012 tenders, and it was done by Reliance Anil Ambani Group with Ariba collaboration. It is not delivering full 125 megawatt yet, but the thing is, at that time, it was first of a kind plant. At that time, there were no 100 megawatt or such plants available. So, and it was using Fresnel system, which is not in the technologies which Malti madam shown earlier. So, it was very new for the power plant generation at that high temperature, 500 degree or so. So, but the thing was, in the installation itself, orientation problems were there. Now they are trying to correct it, but once you install it, it's like you cannot change the foundations and other things. So they are trying coatings and other things. Then the second plant, Godavari plant, that is a 50 megawatt plant, and that is running very well. The O&M cost is hardly 1% of the capex, and it is supplying energy at the electricity at the that rate which was awarded at that time of 12 rupees something, which came out after the reverse bidding. All these and the third plant, MEIL plant, this is in Anantpur. This is also not generating 50 megawatt. It is generating around 25 to 30 megawatt. But again, there was some direction problems and installation issues, which again, in any first plant, you will one can see such things can happen. But the Godavari plant, that plant was installed, erected through American company, and they did everything fine, and it is delivering that rate at full power at that rate. So as such, technology doesn't have a problem, but and the balance 6, 7 plants which were shown, they were not installed or did not. One plant, Acme plant, did not work. It was a very small plant, 2.5 megawatt plant. So at very small scale, you cannot have economic power. Then the other three plants, Abhijit Industry, Lanco, and other one, they were the promoters were embroiled in some coal mining controversy. So these plants didn't materialize. Even some parts got ordered in Abhijit Industry, and ultimately custom had to auction it. And they could not get them released also. The Lanco part, they couldn't go beyond the design stage because the plant was to be erected in 3 years, and they were not able to identify design and other things in time. So it didn't go further. And the last plant, that also couldn't materialize because the key person, that 25 megawatt plant in Rajasthan, the key person got somehow he expired, so they didn't do much on it. But they have the land. They have set up the factory for mirrors also, but they didn't go further beyond that because they couldn't start even erection in 3 years. So their PPA got expired in 12 rupees something. So whatever I have described, I have tried to describe that technology itself is not a problem. Had it been, then even one plant wouldn't have worked. But the other plants were not delivering full power, or they couldn't go beyond a certain stage because of other reasons other than technological issues. Now, in all these, what happened was in 2012, nobody was understanding or imagining that storage would be required. So at that time, PV and CSP, both bids were invited, and it was clearly written no other addition can be done, even biomass or other thing, and no storage PPA will be given. So this Godavari plant delivers at 12 rupees per unit, erected at that time when the whole world didn't have even 500 megawatt all inclusive, including capacity of CSP, and it takes 2 hours to get the water heated up in the morning to start the plant. In the evening, it has to close. During the day, again, fluctuations are there with the sun and cloud. So in that condition also, it is delivering. And now last year, IndiGrid has bought it. It is giving regular income. Since the O&M cost is hardly anything. Now, with respect to the battery things, in the present geopolitical situation, when 90% of the lithium and other critical battery chemicals are being handled, either taken out in China or getting refined in China, somehow China is involved. And here we have a technology which can be 100% make in India. Everything is available here in India, and we can have firm and dispatchable power without coal 24/7 through this technology. Not only that, we can use heat directly for industrial or building heating and even for cooling. We are putting up peak load plants, putting up coal-based plants to meet the peak load or the evening load or the night load, or just to cater to the difference between base load and the peak load. Because that peak requirements, base load is hardly 180 megawatt, but the peak load is 250 megawatt. So for that balance in gigawatt, and we are putting up those plants which don't run even for 10% of the time. But if we have heating and cooling through this concentrated solar things, we can reduce our requirement of electricity. MNRE is a Ministry of New and Renewable Energy, not only renewable electricity, that too only intermittently through PV. It is energy. Heating, cooling, all require energy. Hydrogen production, SAF, other derivatives, ammonia, fertilizers, they require energy, which partly can be catered through directly heat. And it reduces our electricity requirement tremendously. Converting heat to electricity is 70% losing the efficiency. And that too for a country where we are putting up more and more coal-based plants just for meeting renewable capacity requirement, saying that we are putting more intermittent PV and wind, and that will work only on certain time, maybe 15% CUF. For the balance 85% of time, let us put coal-based plant, because there is no other technology which can supply us, which can firm this power during the day and meet the peak loads and the night loads, which can be a base load case. So CSP is such a technology which can be a base load case. It can defer our installation requirements, capex requirements, because directly it can cater to heat and cooling. So this is there. It can be totally made in India. Now, in the last 13 years after that 2012, at that time PV bid was around 17 rupees and this was 12 rupees. But we didn't go for another bid all these years and we kept on bidding for PV repeatedly. Now we have more than 100 gigawatt PV and here we have only 3 plants which were bid at that time only. And in these 12-13 years, the technology cost has reduced by 80%. Now China has recently awarded 3 plants of 350 megawatt each at equivalent to 6 rupees per unit if we convert it to Indian currency. And last year they had awarded at 7 rupees. But initially in 2015 they started and they awarded 20 CSP plants of various technologies at feed-in tariffs. Now the result is they have an ecosystem of more than 500 suppliers. One company, Kosen Solar, has installed more than 1000 megawatt plants CSP in China itself, and some are being installed outside also. And they have more than 250 patents for various technologies inside being used. So this is what in 12 years it can happen in China, and in 15 years we are, or 13 years we are not even bidding again. Now presently across the world during this 13 years the capacity of CSP has increased to 7.5 gigawatt. In this only 7.5 to 7.5 gigawatt, 7 gigawatt installations, the cost has reduced by 80%. And presently it is getting reduced in PV and other technologies or in coal-based technologies, that cost is increasing. Here it is getting reduced. This is the only technology where we can jump in even now and get firm power at much lesser rate for next 50 years. We have to install once and then enjoy for 50 years, whether we want heat, whether we want electricity or cooling or hydrogen or other things. Recently, there was some plant is getting erected using CST and electrolyzer technologies for hydrogen production with ThyssenKrupp, TKIL, and a foreign company, So High Tech. Although the promoters are Indians only, but they couldn't do anything here and they had to go to Spain and then they are bringing technology here. Similarly, Kosen Solar has also tied up with 2 Indian companies here. They are ready to install. John Cockerill has signed up with L&T for, they are now looking for some plants in UAE and other things. But in India, we are not coming up even with the bid tender also. So the thing which can bring down the cost of power to less than 6 rupees or 5 rupees, and with time it will say 1 gigawatt we install at 7 rupees, next gigawatt we install at 6 rupees, but we have to have tremendous amount of storage, say 100 gigawatt plus 24 hours or 15 gigawatt hours storage. Now if that much plants we can install, our cost will be, average weighted cost will be around say 3, 4, 5 rupees only. First, second plants only give us experience and these costs doesn't matter. Afterwards, if the cost is reducing and no pollution, for a country like India where our out of world's top 100 cities, most polluted 90 cities are in India only. We are having maximum deaths due to pulmonary diseases, respiratory diseases. Productivity is getting lowered with time. As the GHG emission is increasing, temperatures are rising, and maximum effect of temperature rise is happening in India itself. And we will be requiring more and more air conditioning. Our drought patterns, rain patterns are getting changed. Our agro things for surviving will have difficulty even in growing our wheat and other things, because the environment is changing. So if we can control pollution, we can control rise in temperature, all these things, and without, I'm not saying battery should not be used or another technology should not be used. Every technology has a place. Battery will give us instantaneous backup or up to say 2 hour, 3 hour backup. But if we see today, molten salt storage or thermal storage has 90% of the backup capacity available. Out of the total backup available in the world, battery is hardly minuscule. Even if we install 1 gigawatt CSP with say 12-hour storage, in one instance in 2-3 years, we can have 12,000 megawatt hour storage available, and that too not charged with first making electricity and then discharging it. Here we will be having heat as a stored thing, and we will be able to convert it to electricity or use it directly as heat or directly as cooling or for various applications as and when it is required. And that too during the night time when sun is not available, or for ramping up during the evening peak or morning peak when the PV is not able to generate that much, or during the day when PV gets curtailed and you don't have even to, if you see today also, there are more than 43 gigawatts PV plants which have been awarded, but nobody is signing PPA for them. Similarly, for coal-based plants, tenders are getting awarded, bids are there, and some of them get award also. Then our SERCs have played some active role in UP, in Rajasthan, that they are not allowing. They are saying if you invest today and after 5 years the plant comes, what will be the use? For next 25 years when we have to remove coal, and it is not required at this stage, even in the resource planning. But for PV, we can have a replacement here. It is a complementary technology. It is not competing with PV. It can make that PV also firm, and moreover, for efficiently cost-effective hydrogen, it is there because it gives the heating, and with SOEC electrolyzer, the efficiency is 38 units of electricity required with for 1 kg of hydrogen. In other cases, it is 60 or 50, depending on the technology and the parameters required, units of electricity per kg of hydrogen. Then, if we produce ammonia using CSP and CST, concentrated solar thermal and concentrated solar power, we can produce cheaper hydrogen, and ammonia can be produced at less than $400 per ton. So that will bring our fertilizer subsidy hugely. Presently, 90% of the fertilizer cost is being provided as subsidy to the fertilizer producers, so that the fertilizer price remain controlled. Now, if we can have cheaper ammonia, less than the imported ammonia, that is a gray ammonia or black ammonia, and here we are having green ammonia. And that too, when we have more than 500 gigawatt of 24/7 CSP based electricity potential available, the DNI areas where DNI is more than high DNI areas where DNI is more than 1700 per year. It is available in Gujarat, Rajasthan, Ladakh, in south in Andhra, Telangana. So we have huge potential. And now the policy side, the bidding should, tender should come, bidding should be there, and again some demonstration, research demonstration with innovation plants should be encouraged. People are here who are having plans to put up at less than 10 crore per megawatt CSP plants. But who will give them first 10 crore? Now L&T has tied up with John Cockerill. They are ready to install at less than 9 rupees per unit electricity LCOE. I mean, it is not that way. Like capex would be like this, that it would be less than 9 rupees, provided the tender is for 1000 megawatt, so that they can do the manufacturing here itself. For coal-based plant, we remove custom duty, we give them waiver, we give them land. Why not for CSP? And when the capital cost capex in recently awarded projects, it is more than 12 crore per megawatt of new coal-based plant. And every day you have to put coal. Every time you have to put coal and have that SOx, NOx, GHG emissions, dust, ash. And here you don't have to put anything. All this 12 crore per megawatt. Next plants can come up at less than 12 crore per megawatt when the ecosystem develops here. And nothing has to be put. No coal has to be given, no oil has to be given, and no pollution has to be controlled. So there is enough scope. And with the evolving technologies, new coatings, new ways of installation, robotics installation, drone-based condition monitoring of mirrors, receivers, the human costs in O&M are reducing. Accuracy of diagnostics is increasing. Even this 1% of the capex of the OPEX, OPEX is 1% of the capex, that can also reduce with time. Then the last point, with respect to the materials used, these are very benign to environment. Even after 100 years, if you recycle glass, you can make it again fresh glass. If you are using molten salt storage, you can use those NaNO3, KNO3 as fertilizers later on. They can be converted to fertilizers. So it has huge salvage value also. Even if you install 15 crore per megawatt today for CSP, you can have tremendously high salvage value even after 50 years. And electricity is at less than coal-based plants, because the life is more than 25 years and no R&M or no daily coal is to be burned and pollution is to be there. Thank you. And Dr. Malti Goyal and Dr. Mahesh.
Thank you very much. You are very much averse to coal use in power generation. I go that.
I said all the technologies will be required, not ours, but new coal base has to be seen in comparison with the whole world is coming out of the coal. They are decommissioning their last plant, and we are putting up more than what we have in next some years. And then we have a Viksit Bharat 2047. We want energy independent also. So here is a technology which can make us energy independent, cleaner, greener, and our hydrogen derivatives, SAFs also can be catered to through this. Best part is heating, cooling can be catered, and without putting new capacity, even the existing capacity. And Ajay, you had said about the land requirement. So land requirement, if you see the amount of electricity generated, PV is having 3 to 4 acre per megawatt for 15% CUF. And these Chinese plants for 350 megawatt are having 10 acre per megawatt land requirement, and that too for 60-70% CUF. So the land requirement is getting only 2.5 times, but the CUF is getting many times more. And that too at that time when you don't need to curtail those PV things. PV will get curtailed in that area, that time, but this can cater to other than PV hours. So land requirement is not much, the cost is not much, especially when the lifespan is much more. Environment benignness is much higher. It has the least carbon, embedded carbon per unit of electricity generated. Hardly it is 10 gram. For PV, it is 50 gram per unit. Thank you.
Scale of the plant in operation or under construction, let's hope that we agree to take it forward with the technology we have and identify some of the problems which we are facing in implementing it. Thank you. Thank you very much for your analysis. I now invite Professor Manoj Soni to address the participants about R&D challenges
Sure.
and
Okay.
solutions. Professor Soni, as I said before, is a professor from West Pilani. He has been working on this for quite some time. And he will be giving exposure about the R&D issues and also the priorities for solar thermal and solutions. Thank you.
Is my screen visible?
Yes.
Presentation. Is my presentation visible, ma'am?
Yes.
Yes, it is visible.
Yeah. Okay. So let us start with the related challenges in implementation of CSP and role of R&D. A lot of points have been covered by Mr. Varshney and my previous speakers. I'll come back to very fast about because of limited time. There are a lot of issues related to low temperature storage. There is no issue, but medium and high temperature storage, there are significant technical as well as scientific challenges are there. So scope is here to the challenge related to material, component, system integration, durability as well as the economics. Then for the storage, we are looking at sensible heat storage, latent heat storage, especially the phase change materials and thermochemical storage. Purpose here is to have high energy density and economically viable as well as long-term durable technology. CSP system is a simple system where we are focusing sunlight onto the receiver from the help of mirror, and then we are achieving higher temperature. Then that thermic oil or the heat transfer fluid then comes to the storage tank where the energy is stored. So in terms of hot fluid, it is stored in the hot tank, and then remaining goes into the system where it runs the Rankine cycle. So through it passes through the boiler, and then the balance of system like turbine, condenser, pump, and all, and then goes back into the collector domain. And so this is happening during daytime. So excess heat is stored in the hot tank, and remaining is utilized for power generation. And during night time or off sunshine hours when there is no sunlight, so now the hot fluid flows from the hot tank to the cool tank, and in turn heat the thermic oil, which in turn heat the your water converted into steam, and that Rankine cycle drives here. So current issues with the storage, especially the sensible heat storage, which is most commonly used, is the molten salt or thermic oil like Therminol VP1, which is most commonly used. So it requires large volume because the specific heat is low, and so the tank size is high. It increases the use of the land. While molten salt, the operational temperature range is a limitation. It freezes around 200 to 250 degrees centigrade, and maximum temperature also there are limitations here. When there are thermostasis also, which are there because of the temperature gradient, it is leading to the especially the tank storage. It is leading to cracking and leakages in the tank. So the R&D here is the new salt formulation, which is having lower melting point, because once the molten salt freezes, then you have to heat it. You have to supply either just to the steam jacketing or maybe through electric heating. It has to be melted, and then you have to run the plant. Second is improved tank design and insulation to minimize the losses, and as well as to avoid this cracking and all, and better models for high temperature applications. So there are a lot of issues related to high temperature application, typically beyond 560 degrees centigrade of operation, where generally the normal thermal power plants operate. So heat transfer in high temperature sensible storage like molten salt is there, solid bed, concrete. So there are certain issues here that the conductivity or the heat transfer coefficient is lower for the storage medium, and also the convective currents within the storage medium are not adequate, and you need a large characteristic dimension of the storage tank because of the lower specific heat or lower power density. So we have to explore the methods to improve or enhance this and improve the charging, and also to improve overall efficiency. So in order to increase the heat transfer characteristics of the storage medium, the additives may be added like the graphite can be added, metal particles or ceramic fiber or concrete packed beds are used to increase the conductivity, and also to have the uniform temperature distribution within the storage medium. Then providing the stability structure, solid fillers like honeycomb structures of ceramic or metal foams, which will have enhanced the contact area, and with increase in contact area, the heat transfer reduces, and that also reduces the hotspot. Then graded beds, like layering the material of different conductivity. So higher thermal conductivity will be close to the high temperature fluid side, so that we can have higher heat exchange. And then the low cost should be at the center of the beds, and so we can balance the performance as well as make it economic. So this is the fin type structure, and this is a foam structure, metallic foam. So you are increasing the contact area, but at the same time, it will lead to reduction in or increase in the pressure drop, you can say. And you can provide extended surfaces for enhancement of the area and heat transfer, like coils can be provided, longitudinal fins. Plate feed exchangers can be embedded in the storage so that we can increase the contact area and hence the heat transfer. Then modular exchangers like array of smaller tubes so that you can have a better flow of the fluid, as well as have more surface area, more contact, and reduce the path of the conduction. And then tank geometry can be enhanced by putting more baffles and diffusers to control the flow pattern, so that you can have stratification, so that the high temperature fluid remains at the higher level and low temperature at the lower level. So where we want stratification or where we want mixing, then accordingly you have to modify that system so that we can minimize the exergy destruction, you can say, or the losses. These are the fin tubes which are commonly used, you can say, in normal operations. Then, in order to have higher convection advancement and the flow advancement or enhancement, by controlling the Reynolds number, you make the fluid more turbulent, and by that way, we are increasing the convective transfer coefficient, especially which is done in the molten salt tubes. Another is the jet impingement. So local jets or the spargers may be used to increase the local convection, and without having excessive pressure drop. And the control stratification I mentioned, like well-designed inlet and diffuser, so that can maintain sharp thermal stratification for higher useful outlet temperature. This is specifically where we have a single tank which is used for the hot storage as well as the cold storage. So by maintaining the stratification, you can have hot fluid at the top and the cold fluid at the bottom, and you don't need two tanks. Then two separate tanks are required, not required here. A single tank it can be done. Then next area which is have a lot of potential, I'll say, is the latent heat storage. Again, here the issue is with this phase change material, it is having higher energy density. That is the advantage. But the issues are they are having poor heat transfer coefficient, and also the charging, and because of low conductivity, the charging and discharging time is larger. And the second, another thing is stability. That is, it goes for the supercooling or the phase segregation. And because of change in the phase, there is a volume change. So while designing, whether it is, I should say, the spherical system or the cylindrical tubes, and we have to take into account the change in the volume that has to be considered. So R&D focus here is to develop a composite material like graphite additives may be added so that we can improve the conductivity of the phase change material, and stability of the phase change material above 300 and 400 degrees centigrade, that should be controlled. While the heat exchangers which are designed, they should be compact and manufacturable. These are some PCM storage. So encapsulation is also another way of utilizing phase change materials. So where the phase change materials are encapsulated in the form of small tubes or cylinders, or the encapsulated, you can say, spheres, where proper giving the volume enhancement due to the phase change, that catering to be done, and then the hot fluid may flow over it and storing it, and then the other cold fluid can flow and take away the heat. Another is thermochemical storage, has a higher energy density, but still at the pilot scale, you can say. So again, the issue of the low heat transfer rate and complex kinetic and handling solid gas system, especially at 600 to 1000 degrees centigrade. So synthesizing robust redox absorption materials that maintains high reaction enthalpy over many cycles, charging and discharging. You can say in designing efficient solar reactors and generating long-term pilot scale data. These are the priorities here. Then another issue is the degradation of the material, especially when we talk about the heat storage medium. So that is another core area, you can say. Corrosion is there. So molten salt and PCM, they react with the steel and nickel alloy, the tank material and all. So that is one issue. Then fatigue. So decade of this thermal cycling, charging and discharging may cause embrittlement and cracking. So developing advanced ceramic coatings on composite refractories and standardizing accelerated aging protocols. So by that way, the improvements are possible. So these are some pictures I have taken from the research papers giving the material degradation and corrosion taking place. Then next is system integration and control. When we integrate thermal energy storage with the CSP, so it introduces hydraulic and operational challenges like the high pumping power, also the pressure drop, and especially the transient behavior during startup. That is a challenge here. So R&D areas are like advanced control strategies, digital twins to be developed so that we can simulate them and test before implementation, or we can take corrective measures. Then novel heat exchangers and flow distribution concept and method of modularization and scaling. While techno-economic challenges already has been mentioned some part by Mr. Varshney. So here reducing levelized cost of storage by a cheaper material and efficiency, that will be only possible if this type of system. First is the promotion of CSP. That is very important. Storage comes the second. So once this is done, then automatically these things will improve. Then sustainability, we have to conduct LCA and recycling studies. Now, while conducting LCA, when we are conducting LCA, the problem is whatever the data available, because in order to conduct LCA, we need some data is required. But all the data which is available is for European countries. Very less data is available in Indian context. So, whenever we are conducting any LCA related to solar thermal, we have to rely on the European data, and the European environment or the supply chain is totally different as compared to Indian data in the supply chain. So whatever the results we are getting for LCA in Indian context, they are not within Indian context, I'll say, because we are the data set is the European data set, like Eco Invent, etc. Then policy is coordinating with the evolving power systems like PV and wind to define optimal storage roles. So here, for R&D point of view, some objectives are we have to achieve higher energy density with stable and low cost material. That is one area where a lot of possibilities are there, especially in high temperature application. Then ensuring long-term durability at high temperature, improving heat transfer designs and demonstrating reliable system at scale in real industrial application. I would like to also mention here, I visited this no plant, which Godavari plant, which is kind of running fantastically. And this is my third visit. Recently, I visited this last 10 years. So the plant is running perfectly fine. There are certain issues, like especially if I talk about this swivel joints here, where because that as the parabolic trough is rotating simultaneously, the receiver also should rotate. And here there are three joints and these are the important joints where leakages are is a challenge. That is one. Then recently we designed one CSP application for cement industry, and that was a project given by Bureau of Energy Efficiency in collaboration with NCCBM. Everything is designed, but unfortunately there is not a single PTC supplier. The PTC supplier or parabolic trough collector suppliers are available in India, where they can provide only up to 150-degree temperature heat. But when this plant, this Godavari plant, it is running efficiently for 390 degrees centigrade. 393 is the limit, and they are operating very effectively at 390 degrees centigrade. The thermic oil. So when such plant is already operational since many years, but unfortunately there is not a single vendor available which can supply a single PTC, because we wanted to test one single PTC of the same scale as which is available in this plant, which is Eurotrough ET150 of that scale, because that level only we can get the desired temperature. And there are huge opportunities are there in industry once we enter into that temperature range above 150. Like Mr. Varshney mentioned earlier, apart from power generation requirement, we need more heat than power. Electrical requirement can be met by other sources like PV, wind, etc. Even our ocean, we have not explored so much the wave energy and all. So there is a huge potential there. But where we need heat, so now earlier the coal was being used, now the gas is being used for burning and switching. Now some industry they are switching to the briquettes and all. But so there is an issue with the supply chain here. While CSP can work very efficiently, entire India has good solar radiation, and we don't have to rely completely on CSP. Already I visited this Muni Seva Ashram where they are using the CSP along with the biomass system, and where the steam is being generated, and that steam is being used for cooling application, like Mr. Varshney mentioned, heating and cooling both. So steam is used for cooking application, steam is used in that hospital also, and apart from that, that steam runs the VAM chiller, and that VAM chiller, 100-ton VAM chiller, which is running for this entire the hospital. So that is a very good we have a lot of such opportunities. Industries are ready to embrace this situation, this technology, and this parabolic trough technology is not new technology. This is age old, almost it's a very mature technology, I should say. Only issue is there are no suppliers in industry in India. The issue why we don't have any supplier, because there is hardly any push from the government side. Like the government has pushed for the PV now, every nook and corner if you go in the city, you will find the solar PV panel sellers are there. If the same amount of push is given for the CSP, we'll find a lot of the CSP applications are there, and this system can be installed easily and the cost can be reduced down drastically once it is promoted for the plant scale. So I was talking about this fuel joint and all here. These are the actual pictures of that plant when I visited recently. This is another dish, concentrated dish, which is installed at Muniseva Ashram, and this is 500 square meter dish, which has very high. This is, I should say, it is to be claimed as the most efficient dish so far. Very unique receiver here, which has been designed and having very high thermal efficiency. It can generate steam up to 110 bar 560 degrees centigrade. The problem here is this technology has been developed by Australian National University and Sunrise CSP in combination. But this can produce only steam. So this receiver, if it can be designed for thermic oil, then it can open a variety of doors for industrial applications where we have high temperature energy is required. But unfortunately here, this receiver is designed only for the steam. So if thermic oil based this receiver is developed, then this technology can be utilized very effectively, and its footprint also is smaller as compared to if you consider Shepler collector or parabolic trough collector or linear funnel collectors. The footprint is also smaller because this is a vertical system and not the horizontal system. While these are further new designs which are developed by one Ukrainian researcher, very efficient design, very this Tiger design can also be further improved upon and have higher, can generate a high temperature also. So such type of designs can be in collaboration with the industry, with academia, and also some research labs, government research, government agencies in combination can be developed, and a good amount of research can come out of it. So I would suggest here that as far as the technology is concerned, especially I'm talking about parabolic trough collector technology, it is mature technology that can be implemented immediately, provided the government come up with a policy of coming up with a megawatt scale plant. China has, unfortunately, China has moved very fast in this domain, and the China is developing the solar tower technology, especially the beam down technology, very quickly. The China is developing and mastering it, and now will become a global supplier. And the Middle East or the oil producing countries also investing a lot into the solar thermal, concentrating solar thermal technologies. But we are far behind, almost 20 years, 30 years behind, I'll say. Still, there's only one plant, Godavari, which is working very efficiently, very effectively. But after that, nothing has happened in India. So it will be only possible, like now all universities, everybody is talking about hydrogen. Why? Because the government has pushed for the hydrogen. If the government will come up with a CSP plan, automatically everybody will be talking about CSP, and there are vendors will be available, technology is available, handholding can be done with the foreign partners, and it can be developed. Why PV has come down in India up to 2 rupees 20 paisa? The reason is the balance of material. We have done a lot of innovation into that, and we have reduced down the cost drastically, and then later on we have reduced down the cost of PV also drastically. The same thing can happen with the CSP also. So I would just stop here. It's very unfortunate that we wanted for our this application into cement industry. There is not a single supplier for oil pump which can handle 200 or 300 degrees centigrade temperature, and for smaller flow rates in India. So these are the challenges because the CSP technology, there's no push from the government side. That's it from my side. Thank you. Yeah, Dr. Mahesh, Dr. Malti.
Yes.
Yeah, I'm done, ma'am.
Yeah, thank you. Thank you so much for highlighting the issues, R&D areas for each of the activity of implementing a solar thermal plant. In fact, Rajasthan is being said to be a solar CST state rather, not CSP but CST state. There are a lot of heat applications exist in various part of the country, which of course we have not talked about. We only talked about the power, but you have given very good examples about the possibilities which can be taken up. Thank you. And the solutions. Now I invite Shri Abhinav Kumar from SECI, who is been associated with the Solar Energy Corporation of India for 12 years. And he has his own deliberations about the CSP technology, whether it will come up or not. So let's hear him and see what could be the way forward. Shri Dr. Anil Kumar could not join because though he had confirmed, but last minute he was called by PM office. Oh, hopefully not for a CSP plant, but something else. So let's hear from Shri Anil.
Sorry, sir, please stop sharing. Mr.
Yes, sir, done, sir.
Okay, thank you.
Good afternoon, ma'am. I have shared a presentation. I think if that could be a screen. Yeah, thank you very much. I think a screen is visible or presentation is visual to everybody.
No.
No, it's not.
It is to us.
No, it is visible.
It's a visible.
Okay, okay. Thank you very much, ma'am, for this opportunity, and pleased to be here for this knowledge sharing session. I think much have been spoken by our previous speakers, and I will be briefly covering the initiative taken by SECI. One of them is development of 500 megawatt. Actually, we were trying to have this 500 megawatt of round the clock supply, wherein a major portion of energy was to be supplied through this CSP component. Balance could be complemented by any other sources. Next slide, please. Uh, in fact, the genesis of this 500 megawatt of RTC power supply goes back to the Vibrant Gujarat Summit in 2024. At that point of time, we have signed an MOU with the government of Gujarat. And subsequently, in order to create some kind of awareness, or we can call basically knowledge sharing, we had a international conference also in this regard in February 2024. And even we have discussed, or we are in active discussion with Gujarat, Andhra, and Rajasthan government for identification of land which has better DNI availability. And at the same time, we were trying to basically the broader context remains the most of the projects what SECI is taking up is based on the bid, own, and operate basis, wherein we generally call for a tariff-based bidding. And in that case, the entity which gets selected will have to bid this entire project on bid, own, operate basis, and will be procuring power. and when we're supplying it to the discoms. Therefore, we were trying to understand what could be the project configuration, how much should be the CSP component, or what should be the contribution from the CSP component, what could be the contribution from other side, be it PV or through some kind of base storage or some any other non-fossil fuel based. And at the same time, one of the main point remains how to estimate the financial feasibility. Mostly what is happening, as far as current status goes, the power, the tariff spectrum is between, I think, few rupees, 1.99 or 2 rupees or 2.5 to it's going till the peak hour, which is around 10 rupees. Therefore, we need to take the basically, we need to understand the willingness of the buying entity or discoms at what price point they could procure, because we run with some kind of simulation or desktop study wherein the tariff was coming higher than what was anticipated by the discoms and all. Therefore, there is a clear-cut requirement of some kind of financial support, whether it is in the form of some kind of gap funding, viability gap funding, or some kind of fiscal incentives and all, which I will be covering in our subsequent slide, in my subsequent slide. I think we can go to the next slide, please. One of the major challenge what we are facing during the site selection and all is basically availability of the bankable DNI, basically bankable solar resource. Bankable solar resource means basically the resource where basically DNI assessment where bankers are also willing to fund the project. Although there are some assessment which is available in public domain also, but at the same time, whether that could be realized or that could be relied for the designing of the project remains a question. And because what has been seen that there was some issues with respect to the I think our earlier projects in National Solar Mission for the CSP, where the actual DNI availability was different from what was estimated at the time of designing. And another aspect remains basically large and contiguous and relatively undulated land parcels. The second aspect, what we are seeing, we have the limited domestic manufacturing capability currently in the country, and we have certain supply chain issues, which makes us more dependent on our basically global suppliers and all. And considering the current geopolitical situation, that may have the certain risk of currency as well as which may be reflected in the cost also. Next comes the one of the limitation, because all these buying entities are may not be very much inclined to what form of electron we are supplying them. They may be interested, or they may be better inclined towards the cost of that electron. Therefore, this technology will have to compete with the existing power mix, be it solar PV with storage and all. And what we have seen, the improvement per se in last 10 to 15 years, what has been achieved by the solar PV, or in the recent time, in last 2 years or last 1.5 years, what we have seen, this PV along with the battery energy storage is becoming somehow firm and dispatchable also. Therefore, this technology will have to compete, the CSP will have to compete with the PV plus storage or a combination thereof. And as far as, because this, if we are talking about the CSP in complementarity with other source, we have limited operational experience where this projects we are yet to see for a considerable time period where we are seeing how this PV as well as CSP are giving us a firm and dispatchable power. Therefore, that is another aspect. Next slide, please. And undoubtedly, this has the high upfront capital cost, which makes, I think, funding a major challenging issue. and at the same time there are very few basically lenders who are willing to take the risk, because there are unfamiliar risk. The risk has to be determined, therefore bankers may will have to assess the cost of such risk. But since we have very less operational capacity in country, therefore bankers are also not very coming forth for funding the project. And undoubtedly, as per Electricity Act, most of the discoms are preferring this competitive bidding process. There it is entirely dependent on the tariff and all. Therefore, buying entities are also constrained by way of this Electricity Act and all. And most of the procurement they are doing based on the tariff-based competitive bidding. Therefore, the higher tariff is making it somehow challenging for them to procure. And this leads to the uncertainty in power sale arrangement. And this power sale arrangement will lead to the bankability issue. Therefore, we need to have some kind of policy signals where we can unlock or we can justify the higher tariff, be it in the form of long-term duration storage. I think we can go to the next slide. Basically, we need to unlock the entire value stack. Take the case of battery also. Battery is able to perform energy shift. At the same time, it could provide you the ancillary support also, and it could complement, basically, it can meet your peak demand. It can provide you ancillary support. It can add to your DSM also, DSM penalty also. It could support you during that time. Therefore, we need to create an entire value stack. What could be the business propositions which could justify the higher tariff also? And undoubtedly, in order to address the initial higher capex, we need to have some kind of viability gap funding. If we are unable to unlock the complete value stack, we need to think beyond basically this tariff-based competitive bidding model, so that we could have some kind of technology diversification also. It may not be prudent to have heavy reliance on few of the technology for our power generation. And if we have some kind of power sale certainty, I am very much sure that we may have interest from lenders and all. And last but not the least, we need to have the domestic manufacturing capability, and at the same time we need to build our own in our, or basically we need to take care of capacity building also. I think that's all from my side, ma'am. If there is any query or question.
Thank you, Abhinavji. I now request Dr. Mahesh Kumar to take the platform for the question answers about the very interesting presentations made. Now we know the viewpoint from SECI also about the difficulties being faced in implementing the plant. So,
may I raise some point, madam?
Yes, Dr. Ramesh Kumar will be chairing the session.
That's
Yeah,
okay.
please. Yeah, please go ahead.
My one feedback I wanted to give to maybe Abhinav Kumar may be knowing, or MNRE may be knowing, that the 100 megawatt plant was commissioned in 2014 by Reliance Energy in Rajasthan at Pokhran site. And this plant has a difficulty in startup issues, and therefore they were burning oil to start up this plant quite often. And they were requesting the CRC and the MNRE that they should be reimbursed the cost of the oil, etc. And the CRC said that it is an issue which MNRE has to solve. MNRE was not agreeing to give them the tariff of 15 rupees a unit, which was agreed in the PPA on that plant. But I requested MNRE that, okay, do not give them the 15 rupees, but give them at least the cost of the oil cost. So it only means that at that point of time, our regulatory bodies and the concerned ministries were not cooperating with them. And finally, this plant had so many issues. They were generating the power from an old machine of 60 megawatt, which they bought from somewhere, and so, which had remnant life. And also there were issues with the steam tubes carrying the steam from the concentrated solar panels. And also some of the panels, although they had arrangement of reversing the panels when they are not in use, and but many of them got broken due to many issues. Even birds or some stone throwing or something were happening. The cost was very high, and I must appreciate that this plant has to actually compete with the solar PV with battery system. And unless the cost is comparable or it can compete with that, I don't think that this plant would be, can succeed on a commercial basis in this country. And that is one of the reasons why the plant is not coming up and our confidence is not building. Maybe that one or two plants on an experimental basis can be set up with the help of the government or SECI or MNRE on a large capacity. This 3 megawatt plant which was set up at Gwalpari by MNRE also did not function. And there the availability of the reflectors was a question which was imported from Germany at that point of time, and many of them which got damaged could not be replaced. This is my feedback to you, Dr. Marti.
Thank you. Do you have any observations, Mr. Arvina?
Ma'am, very well said. I think we need to have some kind of regulatory framework basically to enable this. And going forward, this CSP will have to compete because it has the potential. It could deliver the long-term, basically long-duration energy storage also. But it will have to compete with basically solar PV plus battery. It will have to compete finally because the buying entity remains same. Buying entity is the discoms more or less.
Also, this power has to become dispatchable because in any case, the solar DNA is varying during the daytime, morning till evening. So
No,
we can.
but this session that we organized is from the point of view of technology support. You see, administrative support, policy support is a different matter. This is a technology which they mentioned. Am I audible?
Yes.
Yes, sir. Yes, sir.
There is a technology
Yes, sir. Yes, sir.
which is almost 60-year-old. So technology, there is no problem that you are storing the energy in the form of, and then you are again delivering power. So this support of policy. Now, when the other competitive options are there, why is it that so many plants, 10 or 12 plants, which are already either in construction or in operation, why is it that it's not functioning? So you have to find first the perfect the technology. Somebody took care, somebody took steps. The first slide that was shown was about a dozen plants varying from 50 megawatt, 125 megawatt, 20 megawatt. Let us perfect that. Because jumping on this, give that, then it won't work. Then it will be left behind. Somebody has brought battery to some shape. See, just 2 years back, it appeared hydrogen will be the substitute. In 2 years, battery is running ahead of hydrogen now. So therefore, this session, this vertical of India Energy Forum is not a vertical for that type of discussion. It vertical is what is it where technology is an issue and what it is that is to be done. The concept is known. If material is an issue, if in operations of design issue is there, that is making it unaffordable. Volume, you see, in every research, why I feel sometimes quite concerned, and many of us feel concerned, that India does provide volume. Sometimes technology developers, they cry for volume. When I was trying to convert the CFL light to LED, The people, manufacturers were saying, give us volume. And we gave them volume. Through Bureau of Energy Efficiency and otherwise, by coordinating with different state governments, we said, okay, do it for 10 million or 20 million and bring down the price. The price was brought down. So India has that advantage which many other countries don't have, that you don't need to be sort of competing in export market. India provides the volume. So if 20 pieces or 100 pieces or 1,000 pieces, you are uneconomical. Are you economical at 1 lakh pieces of 20 megawatt, 30 megawatt, 50 megawatt? See, today, the policy framework is such that this decentralized solar system in rural area, that needs a backup. And you can have as small as that. Now, 5 megawatt, 4 megawatt, 2 megawatt solar projects are coming, but they will have support, they will need support in the evenings. So it can be a range of this particular technology. But this session, if you want, we can have another session only on that. But this session is not just कि viability gap funding दे दो, ये करो, वो करो. Technology, 60-year-old technology, where are the missing links? And if somebody like SECI, a good organization to provide volume, they can coordinate on behalf of an, made that point, they can coordinate. But the question is that people, DISCOM will be asking. We also are trying to put pressure on DISCOM. The tariff should be low. So I think we should sit together. What are the missing gaps? Viability gap funding को एक मिनट बाद रखो, क्योंकि viability gap funding is by nature of this, that you are providing, one is that you are being provided cheap solar power. That is one, that is itself a viability gap funding. It was not available earlier there. So cheap solar power you are being provided, which is also the case in battery. And then you are being asked to sell at costly power in evenings. So two viability gap funding is by very nature. You see, emergence of solar has given rise to life to these people. Solar needs this backup, so the life has come to these people. So therefore, you have two types of inbuilt mechanism of providing viability gap funding. A cheaper power, cheaper solar, because during daytime when solar has crossed 100 megawatt, 100 gigawatt, as it is we are experiencing throughout the country to back down solar. So instead of backing down, I will use that solar energy for your need. So that is one viability gap funding. And then the evenings, if you see the exchange rates, they vary sometimes. So in the evenings, we give you higher rates. So that is another viability gap funding. So the issue is technology and sort out the technology. We will have another session on this subject because battery has its plus points, battery will have its minus points also. Pump storage also running in the race. And I tell you, within 4-5 years, we will have something like 10,000-15,000 megawatt of solar power. Solar power potential itself is very high. So this is pump storage. Potential is itself very high. So pump storage will also take over. So it has to compete with pump storage. It has to compete with battery. Pump storage does not have the type of problem which battery will have. A 10-year life, pump storage will have 50-year life. So each technology will compete with each other. I think those who ask for sympathy, solar asked for sympathy for 2-3 years. From 15 rupees, it came down 4 rupees, 3 rupees, 2.5. We are not giving value except for transmission. If I have to build, that is a different matter. So I think it is the technology people who have brought it to life. And if you are all the technology people, and as in what vertical Malti is coordinating in the Indian Energy Forum, is not only an overall sort of policy level thing. Its question is, this vertical is on technology. So I will again ask, and we will have more people. You all can suggest who all we bring, and let us study a little deeply into the working of those 10 or 12 which are under construction or under operation, where the shoe pinches. What are the problems that are there, and how can we? As I said, that two viability gaps funding are inbuilt in the process. You go on asking government viability gap funding. We are not giving viability gap funding in transmission. We have opened up transmission. So I think gone are those days where people have to ask for viability gap funding. Manufacturing, there will be something. Means I will put a higher import duty on others to compete with you. So therefore, that is again the viability gap funding. Somebody can buy at 10 rupees from China, and we will put 10 rupees more on tariff. So you have a viability gap funding. You can sell at 15, 16 rupees. So that type of policy things can be there. But not the policy give us money. We have given a lot of money to research people without much result. This is a challenge to research and technology development people. All right then, thank you. Thanks.
Sir, one of the, you said technology issue, one of the issues which comes to my mind is the availability of the parabolic reflectors and the concentrators, which are not available. At least the other one are being assembled or manufactured in India. But this we have to depend totally, absolutely on import. And replacement of this is becoming very, very difficult at one or two sites wherever these are installed.
No, as I said, Verma ji, the question is, we will have another session on this technology issue.
Yeah.
Where are the gaps area from technology point of view?
Right. Okay.
Design point of view, operational deficiency point of view, and then we fill up the gaps from policy point of view, regulatory point of view, and in the end, if some financial support is needed.
Right.
Thirdly, how do we support the manufacturing to come up in India? So that we can have another session on this. I will have to take leave. I have another meeting, but you can continue. Okay? Thank you.
Okay, sir.
I think we can wind off.
Yeah.
Malti ji, I would like to compliment you for the organizing this webinar on the launch of the new vertical. As Shai Saab mentioned, we would be focusing on the technological aspects of the various energy segments. And I would like to compliment the various speakers from CSIR, from NTPC, from BITS Pilani, from SECI, for successfully sharing the information, may not be exact technological aspects, sharing the technological information on the CSP aspects. R&D aspect, definitely we would like to cover more, maybe in the subsequent programs. And I'm happy to announce that V.S. Verma ji, who's heading the renewable energy vertical in IEF, will be organizing one such seminar in mid of February next year. Maybe whatever deficiencies in today's programs have been mentioned by our president, we would like to cover that. Nevertheless, the speakers have given a lot of in-depth knowledge and information on various aspects of CSP and the role of R&D in that. I hope Malti ji will cover other areas also with the equal enthusiasm. Her background has been renewable energy, so first topic she has selected under this vertical is on that only. But I believe she will be covering the other energy sources also, like the nuclear or the thermal or hydro, etc. And the technological aspects in those she will be highlighting and bringing it to the wider knowledge and information. Once again, on behalf of India Energy Forum, I would like to thank all the eminent speakers for making this presentation in the webinar very, very interesting and knowledge sharing. Thank you very much. I hope to get your support in the future programs. Thank you.